Hello everyone, welcome to VT Data Engineering channel. Today I am going to talk about streams in Snowflake. Streams are used to capture change data, and before we move on to streams, how they are defined, how they work, I am going to talk about change data capture in detail. So change data capture CDC, it refers to the tracking of all changes in a data source so they can be captured in destination systems. So, as we know, data is very important for every organization, and it is also important to make to have conflict-free and real-time data for better decision making. The data is constantly changing in all the systems, so it is always important to maintain integrity and consistency across all systems in the organization. So with the help of CDC we can achieve the data integrity and consistency. Mainly there are two methods of change data capture. So one is push and pull, and in the push method the source database does the heavy lifting. It implements logic and process capture changes in the database, then sends those updates to target system so they can take appropriate action. So the advantage of this method is, since source system is doing all the process and sending data to target system, it can send real-time data. However, the disadvantage is if the target system is not available, then the message is lost. So in order to fulfill that gap, usually like now we go with messaging system in between, so that like the messaging system ensure that the data is captured by target system. And the other method we have is a pull. So in this method the heavy lifting is done by target system. Source system, it just captures the change data in the form of columns. It could be audit column, last updated timestamp, or last inserted date. And target system will go and pull the data from source system. So since target system doesn't know, like in real time when the data is getting updated, so on time basis, probably for every 5 minutes or 10 minutes it goes and pull the data from source system and get it into the target system. Again, in this case also, if source system is not available, data could be lost. So in this scenario also we can have message system in between, so that it can ensures that all the changes that happen in source systems are captured by target system. In the pull method, since data capture is happening in batch mode, so there will be a lag between source and target. So the fundamental approach here is, in case if we are looking for real time data, we can go for push. In case if we are looking for a in a batch mode, if we can process it, so then we can go for pull method. And there are three change data capture patterns. So first one we have is a timestamp based database. Architects usually add audit columns to the source database whenever there is any insert or update happen. So these audit columns will be populated, and the target systems captures based on the last modifier or updated dates since the last execution. So this method is very simple to use and implement. Whereas uh, if the data is deleted, so you don't have the record in the source database. In this case, since you are going and picking up the data based on last modifier or last updated, you would not find that record. So which means that if the data is hard deleted, we would not be able to capture using timestamp based approach. And the other problem that have, since we want to see what are the records that are updated from the last execution, we need to scan the entire table, so that would cause overhead on the database. And this is just example how timestamp based would work. So based on the last modified date, we would be capturing and storing it into the target system. And the other approach that we have is a trigger based change data capture. So most databases support trigger functions. So trigger functions are stored procedures that are actually executed once a specific event, such as to insert, update, or delete a record, occurs on a table. One trigger for each operation. So one trigger for insert, one trigger for update, or one trigger for delete. So in this case, we don't lose the data, since we are capturing all the operations of data. Hard deletes also captured, and triggers are widely used and supported by majority of databases. The negative impact is, since every update or every insert or every delete is triggering stored procedure, so it would cause overhead on multiple writes. And since we are defining the triggers, so we need to change the source database schema as well. And here is the example how the trigger based would work. And the third one and last one we have is log based change data capture. So transactional databases log all changes, either insert, update, or delete, that are committed against the database, and their corresponding timestamp into files called transaction logs. So whenever there is a change happen to the database, it writes to the transaction logs. So these logs usually created for backup purpose. However, we can use them for a change data capture as well. So it doesn't, since this is a inbuilt function of a database, it doesn't cause any overhead to the source databases, and we can capture all changes since it's writing logs for every operation. So we can capture all types of changes in the log based change data capture. And when it comes to a cons, so there is no standardization around the format of logs. So each vendor can implement the log based approach in their own way. So, and one more approach here is, for every operation, either let's say source system made a change and revert the change. So it is like, it's basically restored to the original position. However, this log capture both change, so it doesn't tell, like, whether the change is actually reverted. So that is the disadvantage of using log based change data approach. So here is an just example. We have a source database where it gets insert, update, or delete operations, and once these operations happen on the database, they log into transaction logs, and the log miner reads these logs and sends to the target database. I hope you got the concept of CDC. And in the next session, I'm going to talk about how this CDC can be implemented in Snowflake using streams. Thank you for watching.